In this video, we are going to learn about the way we measure angles in a coordinate plane. When you talk about an angle in a coordinate plane, we usually speak in terms of standard form. Alright, we are talking about an angle that's formed by two rays. One ray we will call the initial side of the angle, and the other ray we will call the terminal side. So if you look at the yellow angle that I've just shown, this would be in standard form if the initial side is the positive x-axis. And then you imagine that you took that initial side and you rotated it this way, and imagine that it ended up here at the terminal side. Now, a counterclockwise rotation like this is actually going to be a positive rotation. So however many degrees this is, let's say this was 135 degrees, this would be a positive 135 degrees. If we went the other way, alright, still using this as the initial side, but if the terminal side was here. So imagine that instead of going counterclockwise, imagine that we rotated clockwise. This would be negative 135 degrees. Let's talk quadrants. The quadrants go around this way. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. You really have to memorize that. Now, it's customary to use Roman numerals for these. So you will often see the first quadrant this way, second quadrant, third quadrant, and then this is a Roman numeral 4. Alright, so keep that in mind everything we do, what quadrant we're in. Now, you can think of an angle as wrapping around more than 360 degrees, but we'll get to that. Imagine that I went 90 degrees. Alright, this is called a quadrantal angle. That would be a 90-degree angle. The next quadrantal angle would be if I went around to here. How many degrees would that be? Alright, if this is my terminal angle, then what you just witnessed was a 180-degree angle. And you can keep going and have this obtuse angle. Alright, if you go, what if I went 3 quadrants like this? And alright, so my terminal angle was here. Alright, 3 times 90 is 270, so this would be a 270-degree angle. And if you went all the way around, that's not an eraser. Okay, imagine that you wrapped all the way around like this. That would be a 360-degree angle. So you can have a 360-degree angle now that we're measuring angles on a coordinate plane. But the crazy thing is, you can have an angle that's bigger than 360 degrees. You can wrap around all the way and keep going. So imagine that I went all the way around, back to where I started from, and then I went one more quadrant, like this. So here's my terminal angle. The terminal side of my angle is going to be right here. Now you might be thinking, well, that's just 90 degrees. And without this curly arrow, it would look like 90 degrees. But the curly arrow is part of the angle. You can't know what's happening without it. So this is actually a picture of 360 degrees plus another 90. So that's going to be 450 degrees. Okay, now let's get back to the actual assignment. For number 7, we're supposed to give the angle measure represented by 3 rotations clockwise. First of all, please remember that a clockwise rotation is actually going to give us a negative angle. So, if I go clockwise 1 rotation, okay, that's 360 degrees, negative 360 degrees so far. But if I go again, alright, that's 2 times 360 degrees, negative. If I go a third time, okay, then that's negative 3 times 360 degrees. Alright, so that's going to be negative 1080 degrees. Okay, look at number 8. If I want to go 1.5 rotations counterclockwise, now understand that counterclockwise is a positive rotation. 1.5, that's 1.5 rotations. Alright, so here's 1 rotation. So that's 360 degrees so far. But then we're supposed to continue and go another half of a rotation. Okay, so I'm going to end up here. That's going to be an extra 180 degrees for that extra half a rotation. And let me go ahead and draw my terminal side of the angle, which would be right here. Okay, so now 360 degrees plus 180 degrees is 540 degrees. So that is what we are looking at here. Okay, number 9. 2.25 rotations counterclockwise. Alright, again, counterclockwise is a positive rotation, so keep that in the back of your mind. 2.25, well, 0.25 is 1/4. So this is 2 1/4 rotations. Alright, 2 1/4 rotation. So let's look at that. Okay, so 2 rotations. So here is 1 rotation. That's 360 degrees so far. Here's another rotation. That's another 360 degrees. And now here comes the quarter rotation, would be right there. Okay, so that is going to give us our the terminal side of the angle will be right here. And let me not forget to add on that 1/4 of a rotation, of course, is 90 degrees. So 360 plus 360 plus 90. Alright, that's our 2 1/4 rotations. That's 810 degrees. Okay, for the next part, we're supposed to identify all the angles that are coterminal with each angle. And then we're supposed to find 1 positive angle and 1 negative angle that are coterminal with each angle. So we're going to find an expression or a formula of some kind for all coterminal angles, and then we'll have a positive and a negative. coterminal angle. So let's go to the black screen. Negative 45 degrees. What would that look like? Alright, so negative 45 degrees is going to go clockwise like this. This is the negative direction. And so 90 degrees would be all the way down here. 45 degrees is halfway. So we're talking about something like this. Okay, so this is what negative 45 degrees would look like. Alright, now the thing is, when we talk about coterminal angles, we're talking about angles that will land on this same ray with their terminal side. So you know how we can have additional angles by going all the way around. So imagine that instead of just going negative 45 degrees and stopping, imagine that I went negative 45 degrees, but then I went all the way around another 360 degrees. So that would be a coterminal angle. It would land on the same ray. Okay, so that would be, so I went 45 degrees and then a full rotation. So that would be 45 plus 360. Alright, so that's 405 degrees, but be careful, this is a negative rotation, so it's all going to be negative, negative 405 degrees. So that would be a negative coterminal angle. So we might as well write that down. So negative 405 degrees. But the reality is, we got that by going 45 degrees plus 360. But couldn't we do that over and over again? Couldn't we go another 360 and another 360 and another 360? So if you wanted a formula for all of the coterminal angles, you could take your negative 45 degrees, but then you could either subtract 360 from both sides multiple times. So I'm going to use a variable of n to represent 1 time, 2 times, 3 times, 4 times. So I could either subtract or I could add 360. It really doesn't matter. So this time I was going negative, so that was like subtracting 360. But I could have done the same thing the other way. Alright, I could have gone my negative 45 degrees, and then I could have, after that, added 360, and another 360, and another 360. Alright, the repetition is the n. So you could have a formula representing all of the coterminal angles if you start with your initial angle and then add or subtract 360 degrees in multiples of n. So I guess we should say where n is a whole number. Okay, so that's one way you could do it. Now let's talk about finding a positive coterminal angle. Okay, so remember, this is our original angle here at negative 45 degrees. So if I want a positive angle that has the same terminal side, then I'm going to have to go around in this direction. This is the positive direction counterclockwise. Okay, so if I came around to right here, that's the angle that I want to talk about. Alright, now the easiest way to think about it is imagine if I kept going with it. Alright, imagine if I kept going all the way to here. How many degrees would that be? Well, that would be a full trip all the way around, so that would be 360 degrees. But I didn't quite go all the way, did I? I stopped short, so I'm erasing this part, so I'm taking away that last 45 degrees. So you can think of it as 360 minus the 45 degrees. So that's going to be 315 degrees. Alright, so 315 degrees. Alright, let's look at a couple more of these. So number 11, 217 degrees. Alright, when I do these angles, I always look at my quadrantal angles as I go around. So I'm shooting for 217 degrees. Now I know if I go this far, that's 90 degrees. If I continue on and I go this far, that's 180 degrees. If I went on and I went this far, that would be 270 degrees. That's too far, so I know I need to back up, and 217 degrees will be somewhere. What quadrant is this? Quick, what quadrant is this? That's the third quadrant. Alright, so we know it's going to be somewhere here in the third quadrant. Okay, so I'm just going to draw it like here somewhere. Okay, so this will be my 217 degrees. So we're supposed to find a formula for all of the coterminal angles and give an example of a positive coterminal angle and a negative coterminal angle. So just like we talked about before, if I take my initial angle, I can get all of the coterminal angles by going around and around 360 degrees. Alright, if I go around one time, coterminal, 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 however many times I want. So that's 217 degrees plus 360 degrees n times, alright, where if n is a whole number. And so just then I was going clockwise, but I didn't have to. I could have gone counterclockwise. So if I start from my 217 degrees, but then I go minus 360 one time, or two times, or three times, or however many times I want, then all of those would be coterminal angles as well. So, as we did before, all of the coterminal angles could be written as 217 degrees plus or minus 360, and we'll put an n there to represent one time, two times, three times, or n times. Okay, so 217 degrees plus 360 n, plus or minus 360 n, I should say. Okay, now let's give a specific example of a positive coterminal angle. Alright, so if I want just one example, I can just simply take my 217 and add 360 degrees one time. Alright, it would be this coterminal angle. Okay. So 217 plus 360. That's 577 degrees. Alright, similarly, if I want a negative one, I can go, I think the easiest way to get the negative one will be to start from 217 and go all the way around in the negative direction, so minus 360 degrees. So if I started from here and went negative 360 degrees. Okay, so that's going to be negative 143 degrees. Alright, so let's be clear that that's negative 143 degrees is the same thing that we would get if we started in standard position and went negative 143 degrees directly. Alright, we'll do this last one without drawing a picture. If we want an expression for all of the coterminal angles, we can go negative 305 degrees plus or minus 360 degrees n times, or n is a whole number. So if I want an example of a positive one, I can do what I'm showing here. I can add 360 degrees. So if I do negative 305, which is the original, plus 360 degrees, that's just going to be negative 55, that's going to be 55 degrees, positive 55 degrees. So that would be an example. And if I want an example of a negative coterminal angle, I can take negative 305 and subtract 360 degrees. So that's going to be negative 665 degrees. Alright, I'm going to do one more and then put a stop to this video because it is getting quite long. So just remember, it's sort of the opposite of what you might normally think, because counterclockwise, counter means against, but counterclockwise is actually a positive rotation, and clockwise will be a negative rotation. Okay, so just keep that in mind. So we're supposed to find the angle that is two counterclockwise rotations. That's two positive rotations from 60. Okay, let's do that first. Two clockwise rotations from 60, that's going to be 60 plus 360 times 2. Alright, the 360 times 2, that's 2 positive rotations. Okay, so that is going to be 780 degrees. Alright, so we're supposed to then find the angle that is 3 clockwise rotations from 60. Right? Okay, 3 clockwise rotations. So because we're doing clockwise, we're doing negative. So start from 60 and subtract. So we're doing 3 rotations, so that's going to be 3 times 360. Okay, so we're subtracting 3 times 360 because it's 3 rotations. We're subtracting because it's clockwise. So that's negative 1020. Whoops. Alright, that's it. And let's put a stop to this video here. And I've still got more problems I want to do. Alright, handful of more problems, but we're going to definitely pick that up with another video.